Welcome back to the Kielder Observatory podcast. I'm Ian Brannan and I'm joined by Director of Astronomy Dan Pye. And coming up in this month's episode, we'll take you to a couple of our recent sessions up at the observatory, but both with very different themes. First was our Space Kids event, which is one of our most popular events which takes place during the daytime and during the school holidays. It ends with youngsters building and launching their own rockets.
3, 2, 1, pull!
And then it was the turn of another of our most sought-after evenings, the Aurora Night, where you can learn about the aurora phenomenon and discover how to see it for yourself.
It's in such a beautiful setting, the views are phenomenal. So that's one of my favourite highlights of today.
We're also talking cosmology in this month's episode too, with Dr. Sam James, who is chair of the North East branch of the Institute of Physics, finding out why we can still see the remnants of the Big Bang.
The fact is that the very last light given off by the Big Bang is actually imprinted on the night sky.
All coming up in this month's Kielder Observatory podcast. Great to have you along with us once again, and as I mentioned at the start of the podcast, Dan Pye, Director of Astronomy at the Kielder Observatory, joins us. Hi, Dan.
Hello.
So in this episode this month, we are going to bring you a flavour of what it's like to take in one of the many different sessions that you can join at Kielder Observatory. There's often different themes that run through them, and what we're going to take you to is one of the sessions that happened during the half-term holidays, which was a double session, really, certainly for me and for everybody who was working there, but for the people visiting, there were it's a daytime session which was set up for kids, where we were launching rockets into space, and that was like a late afternoon tea time kind of event, and those events happened during the school holidays. And then we had an Aurora session where we were learning more about the Northern Lights, the Aurora Borealis, what makes it up and why does it happen, and how do you actually see it. So Dan was present at both of those, so we'll hear more from Dan when we actually play that for you in a little bit. On to this month then. Well, the last month has gone very well. You've had your first full month of being back open, and I know things are not 100% back to normal, but at least you're getting people there in person to the observatory to take part in sessions and have visitors along. How has it gone so far?
Yeah, it's gone great. It's been amazing seeing people come back through the door and welcoming them to the place that we all love to be. And we love being at the observatory, and our main motivation really for every staff member that we have is that we just love to talk about astronomy. That's the thing that keeps us going. That's the thing that keeps us interested in our jobs, and we all love to do our jobs because astronomy is not only just the thing that some of us studied, but also our hobby, our pastime, and the thing that we read about and listen to. So being able to share that with the general public and convey it in a fashion that is understandable and accessible for the general public has been fantastic to get back to that again. And of course, to enjoy the night sky from Kielder, even during the summertime. It's still light at Kielder during the summertime because, of course, we're tilted towards the sun and we experience no real astronomical darkness at this time of year, but that doesn't really take away from the fact that you can see more still from Kielder with the naked eye than you could ever see from a populated area such as big cities like Newcastle or London and places like that.
I'm going to play some of the audio from what happens in these sessions and how they go, but you have a little bit of a chat first, a bit of a talk, and then there's a lot of time on telescopes and stargazing in general. What sort of sessions have you got coming up over the next month or so then through June into the start of July that people might be able to get on?
We're in very short supply. There's most of our later events are all completely booked out. The remaining events, such as the cosmology, the heavier topics, if you like, things like Our Dark Universe, which we run rarely throughout the month, actually. And that addresses the topic of things such as dark energy and dark matter and what are black holes and why are they so important and interesting to us. And then we've got other subjects such as where the universe came from, the origins of the universe event that addresses everything from the Big Bang up to the cosmological web that we're able to see today. So all of those events we still have very limited availability on. But things such as Aurora, Space Kids events, late night dark skies and such like that, I think we're pretty much booked for much of the year now. So there's very, very limited spaces available throughout the summer.
And this is it. You see, you've got to book early. Keep your eye on the website. You never know, there might be some cancellations and stuff as well. So do keep an eye on social media, because that does happen from occasion. That doesn't stop you yourself going to a dark location somewhere across the northeast, or indeed anywhere. And aside from the observatory, where's a good place to check out the night sky? We're going to give people an idea of the things that they can look out for over the next few weeks. But where would you recommend going if they can't get a ticket at the moment to come up to the observatory? Where else is good?
There's some great dark sky locations around the northeast. We're very fortunate because everything is so spread out across the northeast, and being able to cut out horizontal light pollution is a real benefit for us. So if we go to places such as Derwent Reservoir is a great place to go and view the night sky. We've got a really good surrounding of trees which blocks out much of the light pollution. You get a little bit of light pollution from Concert, but the southern sky from there is really, really great. You've also got the beach as well. Don't forget, you can go to the beach and do some stargazing. It's a real great location to do a bit of stargazing, is the beach. And there's plenty of other larger parks when you start to cross into the Pennines and down into North Yorkshire, where you can go to big expanses of really dark areas away from light pollution. Essentially, the idea is to get away from light pollution. The biggest place that you can go and do that is the 1,500 square kilometres of the Dark Sky Park in Northumberland. So you don't have to come to the observatory to witness that or to experience that. You can come to any part of that park. It is public access, and still enjoy the night sky from anywhere in Northumberland.
Fantastic stuff. And so moving on to the next few weeks then, through the second half of June into the first part of July, what are the things to look out for in the night sky? We mentioned, of course, that obviously we've got the lightest evenings now at this time of year, but what are the astronomical events that we're looking for?
This time of year, June, is the peak of daytime and nighttime, I guess, if you like. This is when we start to approach the summer solstice, when we approach the 21st of June. And that's when our North Pole is orientated entirely towards the sun. So that's when we experience the shortest night, if you like. So it's not a great time of year to see some really deep objects at this time of year, but it nevertheless is an incredible time of year to witness the phenomenon that is noctilucent clouds. And I talk about these all the time. They're bits of meteor dust in our atmosphere, 60 miles up in our atmosphere. And at this time of year, the mesosphere, where they're currently sat and being blown around by winds, is incredibly cold enough that it creates these little ice crystals surrounding each little dust particle. And these little particles of dust with the ice crystals are very reflective. So as our North Pole is pointing towards the sun, sunlight is able to skip through our atmosphere and illuminate these stunning cloud structures. And they happen usually between 10 p.m. and 2 a.m. in the morning. They're stunning to see with the naked eye. It's one of those phenomena that when you see it on a camera, it looks very similar to how you see it with the naked eye. And what we're looking for is webby, white and blue shimmering clouds across the northern horizon that appear to be illuminated in the night sky. You'll notice they're very, very different to other clouds that you see at that time of night. And they're just stunning to see because they're double the altitude as to the clouds that you would normally be able to see with the naked eye. Things like cumulonimbus clouds and big storm clouds, even anvil clouds, they reach to about 35 miles. These ones are almost double the altitude of that, all the way up there in the mesosphere, and it's space dust, so that's infinitely cooler as well.
Yeah. Space dust is always. I remember seeing these myself last year, and they're very noticeable. You will know when you've seen one, because it's weird in that it just looks like a normal high cloud, but it's illuminated, and it's, in the darkness or the twilight, it just is shimmering. It is outstanding.
It's really great, and they change as well very slowly as you watch them. They're evolving and all tendril-like and webby and strange, and they just dance across the sky. They are my favourite thing to see in the summertime is noctilucent clouds, and we get some really spectacular displays that we can see across the north of the UK.
Fantastic stuff. And as we move on to our pie in the sky feature, which is something of which you are synonymous with. What piece of sky are we looking at, do you think, in this? Obviously, you said that it's very difficult to see some stuff because of the fact that we've got the lighter evenings. But if you're staying up a bit later, what's the thing to watch out for, or the constellation to search for?
So we've got a great asterism that I want to share with you. Now, an asterism isn't an official constellation. Across the night sky, constellations, just to explain a little bit about what they are, they're dot-to-dot depictions of mythological creatures or beings or objects, which are usually linked to Roman or Greek mythology for the ones that we can see here in the UK. There's 88 of them across the skies, and the reason they exist now in that context is really just for referencing different patches of sky, almost like building up an image of how the heavens look. They had different meanings in the past, but nowadays we just use them as almost like grid reference system. An asterism isn't an official constellation. It's a collection of stars which are in various different constellations, or they may all be part of the same constellation, which look like something recognisable. And the one that we want to pick out this time is the Summer Triangle. And we can see that by connecting three very bright stars. We've got Deneb, which literally translates to, I'm told, bum in modern day English. It's in the bum of the constellation of Cygnus. So it's a bright star called Deneb. Then we've got another one which is called Vega, and then another one which is called Altair. Now, if you connect all three of those together, you'll see it creates this gigantic triangle in the sky that points almost perfectly south. And as we start to swing through into peak summertime, that'll reach the central point of our sky at midnight. And it's just a great thing to keep an eye out for, because this was an ancient object used, or an ancient asterism used, to distinguish what season it was, when there was no way of being able to track calendar systems and things were a little bit stranger back 2,000, 3,000 years ago. They would look for objects such as this to calculate the passage of time, and I think it's just nice to have a look at those objects still today.
So that's in the eastern sky, is that right? You look east and you should be able to see that.
East from about 10 o'clock at the moment, yeah. Is probably the best time to see that, but it'll start to swing through into midnight until it's right above our heads, or right down towards the southeast south.
Asterisms then, your challenge on Pie in the Sky for this month. Good luck with that. Let us know how you get on as well and see if you see any of those. This is the Kielder Observatory podcast. Still to come in this month's episode, as Dan was mentioning, one of the sessions that you can book onto over the course of the summer explores the origins of the universe and talking about dark matter and black holes and all these kind of things. And we're going to speak to Dr. Sam James, who is the chair of the Northeast branch of the Institute of Physics, a little bit later in this episode, to find out a little bit more about that topic and find out about the mysteries of the universe that even the experts are quite confused about. So that's still to come. First, though, let's give you a flavour of what it's like to attend one of the Kielder Observatory events. If you've never been before, imagine that you're right at the top of the hill, you've gone 2 miles up a dirt track, and you're in one of the most remote locations that you could possibly find yourself, and you've got some state-of-the-art telescopes to gaze deeply into space. And we've got two particular events on. Space Kids, which is designed for kids in the school holidays to learn more about the wonders of space, do a bit of stargazing, even in the daytime, and make a rocket as well. And then we had the Aurora session, which was in the evening, which is one of the most popular events that Kielder does. And I caught up with Dan in his natural habitat. What we're doing today is we're taking in 2 sessions because you're doubling up during the course of the school holidays, and it's still very firmly daylight. It's about 6 o'clock in the evening. The sun is shining. It's the hottest day of the year officially, and not many stars to be seen currently, but you do have sessions for kids that are happening. And just tell us what sort of things that you do in these sessions.
Yeah, so it's really good actually being here on a day when it is beautiful weather like this, where we get to see the sun, because of course that is our closest star to us. So we can see that through our special telescopes. We always used to say the same thing about our telescopes, is that we think we might have the largest solar filter in the north. We've got a 16-inch solar filter for our telescope, so we're able to look at the sun, and there's some sunspots on there at the moment as well. So they're doing that in the 16-inch observatory right now. Then we also have another telescope which is looking at stars as well. We can see some stars at this time of year. We can see a really bright star called Arcturus, which NAS is looking at right now, which is about 37 light years away. So even in the daytime, we can still see something that's 37 light years away. So it's not a bad time to come and do some stargazing. There's always stargazing we can do. But the priority of this event really is to launch rockets. And that's what we'll be doing at the end of the event. We've got some bottle rockets which we're launching.
So you say it's not rocket science, but really it is.
Yeah, it is. Yeah, rocket science is the end thing that we're doing today, which is dead easy. I mean, we make it sound like it's really complicated rocket science, but it's not. It's just about creating enough downward thrust to make something go up, which is actually really, really hard.
So that's the session that's happening today. And then later, you have a session for when things do get dark. And the theme this evening is that old chestnut, the Aurora. Not that we're planning on necessarily seeing the Aurora. That's not something you can really plan for. And I know that we've said that this current period of time is not the strongest for it, but it's certainly about learning about how to see it.
Yeah, that's it, yeah. And we do get to see it in Northumberland a few times a year. And these events, these Aurora events, are our most popular events. People love the Aurora. They love the idea of being able to see the Aurora. They love the mystical qualities that it has as well. The way that it looks is beautiful. It's one of the most incredible earthbound sciences that we have. But then, would we call it an earth science? Because really it's influenced by something which is outside of our planet, stuff that's taking place in space, space weather, if you like. So we'll be learning about that a little bit later on tonight. Also, during this time of year, there is other stuff to see as it gets a little bit later. We're able to still do stargazing, and we can see some great stars. And to be honest, even coming to the Northumberland National Park, being away from light pollution in the summertime, you can still see more stars than you could see in a populated area anyway. So we'll see some stars later on. We'll do some stargazing, some constellation hunting. We'll also look at some probably slightly deeper objects, because we haven't got a moon in the sky until quite later tonight. So we might just be able to pick out some star clusters, double stars, towards the end of the event. But this season, I'm always hoping to see noctilucent clouds. That's what I'm looking for during the summertime, is those glowing clouds across on the northern horizon, which are formed by meteor dust. Lingering around in the upper atmosphere. They're spectacular, so hopefully we'll see some of those tonight as well. This is the way that they go. So down here where our cap is, that's where we're going to attach it to a pole, and it'll head up just like that. You can create a nose cone for it if you wish, or you can leave it flat. It's entirely up to you. Aerodynamics is something which you may learn during this experience. And try and keep this bottom area completely open. So we don't want anything covering this bottom area at all. Everything on the top is absolutely fine.
Come on, guys. 5, 4, 3, 2, 1, pull.
I'm Rob. We're from near Chorley in Lancashire.
You've been learning about rockets and all sorts of stuff. How's it been for you?
Yeah, we brought the kids up for the weekend and just trying to introduce them to science a little bit, I suppose. And yeah, I mean, we watch some of the rockets on the telly, Elon Musk stuff. So yeah, quite interested in them at the moment. So yeah, the kids are sort of showing an interest in science, and so yeah, really interested to kind of see what's out there, really. They've enjoyed it, so looking through the telescopes, asking lots of questions.
And building your own rocket, which has been like the finale of this event, really. And we've finally got the rocket launcher working and they're firing off pretty well.
Yeah, they've enjoyed it and the rockets have survived. So, yeah, really good, great to see.
And how have the kids found it?
Had a good time?
What's your name?
Jessica.
Okay, Jessica, and what was your favourite bit?
Where we get to make our own rockets and see the sun through a telescope.
Oh yeah, because you were able to look at the sun here, weren't you?
Yeah.
And what could you see?
You could. It's actually. Most people think it's orange, but it's not actually. It's white.
Yeah. How did your rocket go? Because I think yours was the first, wasn't it? How did it end up?
Well, it ended up being wrecked because it didn't land like my brother's did. It didn't land like that. Mine went downwards and it broke
It
the
left
top.
half of its body on the launch pad, didn't it?
But it flew, that's the main thing.
It did flew, but it didn't go very well.
It was fine.
Brilliant.
Good stuff. You had fun though, didn't you?
Yeah.
And now are you going to be more interested in learning more about rockets and space and the sun and things afterwards?
Yeah.
My favourite part of today has been learning all of the bits about space and the rockets and seeing the the space rocks. But above anything else, even if you didn't get to see any of that, like today's a really sunny day, it's in such a beautiful setting, the views are phenomenal. So that's one of my favourite highlights of today.
So, come on guys. 5, 4, 3, 2, 1. Pull.
So that's the Space Kids session. As you can hear, some very happy kids there blasting their rockets into space. My favourite was the rocket that blasted off, and they decorate the bottle and you make it look like a rocket, so wrap some tin foil around it, whatever you want to do. And the rocket blasted off, but everything that they decorated the actual bottle with just stayed on the launch pad, completely left behind. Fantastic. And then from later in the evening, from 9 o'clock till about midnight, it was an Aurora session. And the Aurora sessions are particularly popular at Kielder, always get booked up, as you were saying earlier, very, very popular indeed. Tell us about the format of the event, because there's a bit of a talk beforehand for about an hour or so, which really gives people an insight into the science bit behind it and explains the origins of the Aurora, the history of it, and all that kind of thing as well, so people have a full understanding.
Yeah, that's it. And with all the events that we do, we always have this little educational part, because sometimes ultimately that's what we are. We're an educational facility. People come to learn a little bit more about astronomy, learn a little bit more about the night sky, and all of these different topics. And so the Aurora is our most popular, by far, event that we do. Because I think it's such a spectacular thing to see, particularly when we see it on social media, these incredible images of the Aurora. It really sparks people's interest in, well, what is it? Why do we get it? Can we see it from Kielder? Can we see it from the UK? Why is it happening here on Earth? And does it happen all of the time? And so we address all of those questions and make sure we give you a comprehensive guide as to what the Aurora is, how you can view it for yourself, and why we get it at particular times of year and in particular eras as well, because it's not that it happens the same every year. It goes through a secret cycle, which we unveil during this event as well.
So here's a flavour of one of those sessions now. This is Naz, who's explaining a bit of the Aurora.
The history of the Aurora to begin with. There's lots of different theories that they had about the Northern Lights, about what they might have been. So the French actually thought that they were a bad omen, because they had some pretty bright aurora in the sky that managed to make it down all the way to France right before the French Revolution. So because that happened after, they thought that it was a sign that something bad was going to happen.
It's 10:15 at night. It's just about getting dark. I'm with Dan, Director of Astronomy, and he's pointing at a star that I can't actually see. I think you've got gamma ray eyes.
I'm not sure that they're gamma ray. I think
we're
it's
looking at?
We know it's knowing the patch of sky that the star's in, but we can see just up there. There's a little tiny flickering red point of light, and there's the star Arcturus. It's pretty bright.
Oh, I see it.
Can you see it?
I can see
you see
it.
it now?
I can see it. There it is.
It's good, isn't it?
That's
37 light years away, that star that you're seeing there. And it's really, really bright because it's a huge red giant star. It's very similar to, I guess, what our star might start to look like in a good 4 billion years' time or so.
So that was a bit of us doing some freestyle stargazing, I guess you'd say, just looking up at the night sky, which is a huge part of what happens at Kielder Observatory, especially when you're on a clear night like it was. It was beautiful. We could see all sorts of stars as they started to come out. And then to the observatories themselves and to the telescopes and to see what we can see deeper in space. So that was us doing a bit of freestyle stargazing on a break, actually, just as the stars were starting to come out. And then after the initial talk, it was time to head to the telescopes and to the observatories and see what we could see deeper into space. And as it gets darker and darker, different things become more visible. And this was with Natasha, who was in the Sir Patrick Moore Observatory, which is the largest of the observatories at Kielder. And here's what happened. Here's what we could see.
So at the moment we're in the Sir Patrick Moore Observatory, which is one of our observing turrets. This is where we're going to use the 16-inch reflecting telescope to have a look at bright stars and binaries, and then later some deep space objects. Now, it's really easy to find objects with this telescope. I point on the software, I click, and it does its thing. And then I have to move the roof. So can you see just out of the doors there, directly overhead pretty much, there's a bright orange star. That's the dude we're going for. So have a little look, called Albirio. This optical binary, so it's not a true binary, which is two stars that are orbiting each other. This optical binary is 350 and 410 light years away respectively. So those are the two distances of the stars.
Incredible to see these stars through this eyepiece, seeing that light. It's absolutely mind-blowing. And these are stars that you just wouldn't see were you not in a dark sky park. And I'm looking up now through the open doors of the observatory, and the stars are starting to come out. It's incredible looking back in time, really, to galaxies that are 450 light years away, and that light's been travelling through space for all that time since Queen Elizabeth was on the throne. So much has happened in that time. That light's been travelling just to get to my eye that day. The other thing that is great to be able to do on a nice clear night is just look up at the night sky and just see the constellations that are there laid out before you. And Dan, I know you've got a laser pen and you're able to point at these, and that's quite incredible to see that you can just point skywards like that and just talk people through the night sky.
That's, to be honest, my favourite thing to do is in stargazing is to just use a laser pointer and just navigate around the sky. When we get into the real depths of winter, there's objects that you can see with the naked eye, which, you can see the Andromeda Galaxy with the naked eye. That's 2.5 million light years away. Being able to point that out to guests and show them that with our laser pens is phenomenal. And all of the different constellations, when you see them on the sky, they look very different to how you would imagine them on the screen as well. So I think it's a real important part of the event is to just gaze at the expanse of all of these stars and try to make imagery around them that helps you develop an understanding of the structure of the night sky.
Well, as we were doing that, as we were just doing some freestyle stargazing, caught up with a few of the guests who were with us that evening at Kielder Observatory.
Jack. Pauline. And Laura. We're from Ramsbottom in very near Greater Manchester.
So what brings you to Kielder then tonight?
I went a few years ago and had to come again, really. It's just amazing, isn't it? I really enjoy stargazing when I can at home, but because cities are quite built up and it's very hard to actually get a view of anything without a lot of driving and quite heavy telescopes, which there's a lot of here, so it's really amazing to get the chance to see these things.
It's fantastic to see.
It's funny how much more of the sky you can see somewhere that's not light polluted than, makes a massive difference. Just travelling that little bit extra, you can see, it looks like a different sky. Yeah, I wish I brought my camera, I'd do some long exposures.
Yeah. But I'm 59 and I can remember as a child being able to see the dust clouds, in the arms of the Milky Way from my back door. That's impossible now, isn't it?
Whereas I've never really had that. I'm 18, so I've kind of had holidays camping and in places that are slightly less light polluted than like Greater Manchester, but I've never seen somewhere with protected darkness like this, and it's just like you just stare at it for as long as you wanted to. It's really different.
And it's always changing as well, as the night goes on, things move around, and it's good tonight, I suppose, because there's no moon, which helps, of course. And what other things have you seen with the telescopes as well?
The Cigar Galaxy. Cigar Galaxy was the furthest thing we saw. I think it was a bit easier to see because rather than the disc facing us, it was sort of the side profile. So
vision.
yeah, that was really impressive.
You call it the Fuzzy Wuzzy, what was it? The Fuzzy Wuzzy Cheerio Galaxy.
Ring Nebula.
It was,
Ring Nebula.
yeah.
It was,
I think it was a star that was...
It was the Ring Nebula.
Yeah.
It looked somewhat like a Cheerio, didn't it?
And some closer, brighter stars as well. I didn't realise that every star has, or almost every star has planets around it. I had absolutely no idea about that.
Yeah.
I thought they were literally just stars. That's something new.
It's just crazy, isn't it? The Sky Park is amazing. It's really like nowhere else, especially in this country, anyway.
Yeah.
We've got to come back in the winter.
Yeah, definitely.
Definitely.
Yeah, you were saying the time of year was sort of affecting what you can see and what you can't.
Unfortunately, the position of the planets and it's the scale of things. Like you'll look at things in a telescope, but it's a pinprick, and that's 12 million light years away. It's impressive.
Yeah, I know.
It's that's the most mind-blowing part of it all for me. Just the idea that you're seeing things that when the light actually happened with what was happening on Earth at the time, when the light was new. Intelligent life on the planet was so primitive. That whole concept is mind-blowing.
And what you're looking at might not be there now.
Yeah.
That's another.
Yeah.
For all we know, Beetlejuice might have already exploded.
Good, well done.
As you can hear, some very happy visitors and a little flavour of how the sessions go at Kielder Observatory. If you'd like to book your spot, head online, kielderobservatory.org. Now, at Kielder Observatory, we have a talk that happens every now and again through the course of the year called Origins of the Universe. It's next due to happen at the end of July. And it asks the big questions, really, about life, the universe and everything. How did we find ourselves here? And we're going to talk about that a little now with Dr. Sam James, who is a leading scientist and an expert on all things to do with cosmology and the origins of the universe themselves. In fact, he's the chair of the Northeast branch of the Institute of Physics and knows a fair bit about it. And let's hear more about Dr. Sam now from Dan Pye, Director of Astronomy. And Dr. Sam is one person who has actually been up to Kielder Observatory over the past years to deliver talks on this very subject.
Yeah, Dr. Sam is a great friend, and I've known him for quite some years now, and he's an incredibly profound chap to talk to. He's a quantum theorist, or a PhD in quantum theory, which is always an incredibly complex and interesting subject of stuff that nobody really understands. Him himself will even say, I don't understand quantum theory and I have a PhD in it. So anybody who understands quantum theory or who says they do is probably overconfident and lying, I would say. So he's an incredible wealth of information. He does a lot of public engagement. He used to volunteer at the Kielder Observatory. He's now a freelancer at the Kielder Observatory, so he'll be popping up and doing some talks very, very soon. But you can find him also doing these events that are called Pint of Science events, which have stopped during COVID, of course, but I'm sure they'll return very, very soon, where you can go and have a pint and discuss some cosmology. What more would you want with an evening?
So cosmology is a very deep subject, so there is a lot of stuff to go through, and as Dan mentioned there, that the answers are still not entirely there. One question that's posed amongst cosmologists is about the theory of everything, which is a hypothetical framework explaining all known physical phenomena in the universe. And whilst we have some answers about what happens in the universe, they don't all necessarily tie together. So that's what we're actually searching for, and that is the ultimate question about the answers to everything in the universe explained in one theory. The theory of everything. So we'll start by asking Dr. Sam James, how close are we to getting to that moment?
It sometimes seems like physics has moved relatively slowly since the heady years of 1905, when Einstein came up with general relativity and proved the existence of atoms, and then things seemed to move very quickly through the 20s until when we got quantum mechanics sorted out. The problem that we've had with gravity has been persistent for about 90 years now. Well, actually no, 100 years now. when we might actually get cleared up, I mean, it can move very quickly if we have the right breakthrough, if we get the right piece of data, then possibly it could all be sorted out in 10 years, maybe, about the same amount of time it took for Einstein to come up with the original theory of general relativity. But I think at the moment it doesn't look likely that anything particularly massive is coming down the line. We've only had 5 years of since the first detection of gravitational waves. That isn't very much new data to come in quite yet.
What else can we learn on that front about how the universe is always ever evolving, and this infinite space is actually increasing in size?
Well, actually, one of the interesting things there is the question of, is the universe actually infinite, which may actually have a couple of which may actually affect whether we have the ability to actually produce the true theory of everything. Obviously, the universe that we can see, the observable universe, is about, well, we'll say it's 13 billion light years across, which is basically how long it has been for the light to have actually reached us. And as you look out into space, you also obviously look back in time. So the Andromeda Galaxy is about 2.5 million light years away, which means that when you look at it, it's about 2.5 million, you're seeing it about as it was 2.5 million years ago. And then as we look out further, we actually see all the way back to basically the afterglow of the Big Bang, which is very approximately 13 billion years ago. But we can't see past that because there's just not been enough time for light to travel any further. But that doesn't mean that that is the whole of the universe. It could be that the universe is in fact an infinite in extent, or it could be that it has some sort of finite size, and that's actually an open question in cosmology, I believe.
You know, there's one thing that really plagues me with all of the theoretical points and all of the research and stuff that we do into all of these questions. And the biggest thing that I always find as a stumbling block is, do we reach a point whereby we understand so much that we kind of lose sight of new discovery? Is that possibly what's holding us back? Are we so transfixed on what we do know that we're kind of not really thinking about what we don't know?
I think that definitely is a very good point. Actually, I was actually alluding to the fact that if you actually look in certain branches of maths, now I have to be a little careful here because I'm going to have to generalize, but generally speaking, there is actually in mathematics a proof that there can be statements which are true which we cannot actually prove, which does on the face of it produce a bit of a problem, because obviously the part of physics is built on maths, and if there are statements in maths that are true that we can't prove, it seems difficult to see how we could ever actually form the theory of everything. There is one caveat to this, which is a more correct statement is, there are things that can be true which cannot be proved in the framework that they are stated. So that's actually where the infinite nature of the universe comes into it, because if you can, we get round the problem by there can be statements which are true, but then we invent new mathematics to prove those statements, and then that produces a whole new set of statements which we can't prove, and then we can create more mathematics to do it. And if you can ever expand your knowledge, then it's not a problem. And this would come into the idea that if the universe was finite, then perhaps there's some amount of finite knowledge we could have.
And are there theories that you absolutely subscribe to and 100% believed were fact and made sense and you subscribe to those, and then actually some further research comes out that changes that belief and maybe disproves well-held theories, and really you have to start right from scratch with understanding some parts of the universe?
I don't know, actually, one of the small problems actually is that we haven't disproved all that much. Obviously, I mean, the last big discovery for us theoretical physicists was the Higgs boson. So that was roughly theorized in about 1960s-ish, and obviously only discovered about 7 or so years ago. But the thing was, it was discovered, and that part of the theory was proved. There have been a couple of roadblocks thrown up in the theory of everything. In the late 90s, it was hypothesized that the proton should be able to decay, but we've never actually detected it. So that's left us with a bit of a hole in the theory. But mainly, when the theory predicts something, or at least the mainstream theory predicts something, we do actually normally go and find it, which I think is actually the really amazing thing, that we predict these things long ahead of when we actually discover them. And of course, there must have been a point. So in the early history of science, it was much more the other way round. We would observe an effect, and then the theorists would have to spend a lot of time coming up with the correct theory for how it actually works. I mean, even if you think we're playing around by throwing balls around long before Newton told us there was such a thing as a force, for instance.
Yeah.
Even the astronomers had been looking at the planets for a long time before gravity, and Newton came up with gravity, and certainly a long time before Einstein came up with the theory of general relativity, which replaced it. And then these days, we predict the Higgs boson 50 odd years before it's actually discovered, and similarly we predicted that quantum mechanics predicted things like the ability to harness the energy in an atom long before, or certainly a couple of decades before we actually managed it. So I always wonder when the first time in science history is that a prediction occurred before the evidence or the data that came in to actually show that it could actually exist.
Something that I saw being discussed actually over the last couple of weeks was a very good question that didn't really have an answer, because it was just a couple of people that I know that were discussing it. But we talk about the planets and the solar system that we know moves and rotates. We were talking about the universe expanding. Is there any evidence to suggest that the universe itself is moving around in some way, or indeed the whole thing rotates? Is that something that's ever been looked at and discovered?
Well, actually, that's a very interesting question. Whether the universe actually moves is a little bit... that's an open question, because then you'd have to work out whether you believe the universe exists in some bigger universe, i.e. a multiverse. However, we do know exactly which direction and how fast we are moving in the universe, which is always actually always really surprised me. Maybe this is actually the most surprising thing I've ever found, which is, so there's the cosmic microwave background radiation, which is the afterglow of the Big Bang. So it's all around us, and we can actually measure the fact that we know which way. Basically, if you could see the cosmic microwave background, it would light up the entire sky. But what you'd then notice is, if you could look up into the night sky, that some of it would be colder or bluer, and the other half of the night sky would be redder and hotter. And that is actually because we are moving in the cosmic microwave background, and we can actually tell which direction. Yeah, so basically where it looks red and it's red shifted, we're moving away from that part of the night sky, and where it's blue and blue shifted, we're moving towards that part of the night sky. And then we can actually tell how the Earth is moving around the Sun, and then we can tell how the Sun is moving around the galactic center, and so on and so forth. So we can actually sort of pick apart how all the relative motions add together to give us the overall motion in the galaxy. And it would also seem like the entire galaxy, yes, probably is rotating.
I think it's quite staggering for people who are not quantum physicists to hear that so many million years down the line that the after effects of the Big Bang are still echoing through space now.
Yes, that is actually another. When I was studying cosmology, that was another big revelation, which I was very surprised about. But yes, the fact is that the very last light given off by the Big Bang is actually imprinted on the night sky. So it's known as the microwave cosmic background radiation, and you can Google a lovely picture of it, which is basically often referred to as a map of the universe, because it just shows the slight variation in the color or the temperature of the final light that was released, which has now been, due to the expansion of the universe, it was let off as light, but as the universe expanded, it's been pulled out until it's now in the microwave spectrum, so you can't actually see the afterglow with the human eye. And yeah, the colder spots, or the bluer spots in the map, would show areas which were colder and denser, and therefore will have formed into galaxies and such alike. And the hotter areas will have, which were less dense, will probably be the void between, which is the way in which it is actually a true map of the universe.
That's Dr. Sam James, who is the chair of the Northeast branch of the Institute of Physics, talking a little bit of cosmology and the wonders and the mysteries of the fabric of the universe, which is something that even the best scientists are still learning much more about on a daily basis. And we have a session coming up at the end of July called The Origins of the Universe, where you'll find out more about that kind of subject. Check out kielderobservatory.org for more information. And that's it for this month. Enjoy your stargazing wherever it takes you, and enjoy the night sky. Don't forget to find out more about everything that's happening at Kielder Observatory. Firstly, there's the website, which is kielderobservatory.org, and you can also head on to our social media channels as well: Facebook, Twitter, Instagram, the lot. You can check them out. Just search for Kielder Observatory. Follow us on there for regular updates of what's happening, and indeed details of any spaces that do become available on any of the upcoming sessions as well. In the meantime, take care, have a great month, and we'll be back soon with another episode of the Kielder Observatory podcast.